This video, we're going to be going over pages 42 and 43 in your packet. It'll be a nice review of everything we've learned up to this point this week. Let's just jump right in. Number 1, find the perimeter of a figure with vertices L, E, A, R, N. How about that? It spells learn. To get the perimeter, what that means is we have to add up all the sides of the figure. So what we need to do is figure out the distance between each pair of sides. So let's write out all the different sides we would have. We would have L to E, then we would have E to A, then A to R, then R to N, and then finally N to L. All right. So those are all the different sides we're going to have. So what we have to do is find the distance between each of those sides. What I like to do is I do this a little quicker. Instead of going through that whole distance formula, I just look, okay, from 7 to 4, that's 3. So I know my distance is going to be the distance formula, the square root. But the change in x is 3, so I get 3 squared. And then the change in y is 4, so 4 squared. And then 3 squared plus 4 squared, that is 25. So then I have the square root of 25, which is 5. And then do the same thing for each one. 4 to 0, that's a distance of 4. So we get 4 squared. 5 to 2, that's a distance of 3. Notice I'm not worrying about positive or negative, because when I square it, that positive or negative is going to go away. So again, that's 4 squared and 3 squared, so again, that is a distance of 5. Same thing with AR. So again, we're going to get the distance between each of those points. 0 to 0, that's a change of 0 squared, and then 2 to negative 5. It's a little trickier to think about, but if we're going from 2 to negative 5, that's 2 to 0, so that's 2, and then to negative 5, that's 5 more, so that's a distance of 7. So we get 0 squared plus 7 squared, that's going to give us 49, and then the square root of 49 is 7. Alright, next one, Rn, okay, again, 0 to 7, that is a distance of 7 squared. And negative 5 to negative 2, that is a distance of 3. So it's 3 squared. And 7 squared plus 3 squared, that's going to give us 52. That's the square root of 52. And that will be 2 times the square root of 13, which is approximately 7.21. And then finally, our last side, that was N to L, and that's the one that people often forget because they forget to go back. From N to L, 7 to 7 is a change of 0. So we get 0 squared there. And then negative 2 to 1, well, that is a change of 3. So then we have 0 squared plus 3 squared, which is 9. And then the square root of 9 is 3. And then finally, all we have to do to find the perimeter is add up all those sides. So our perimeter is 5 plus 5 plus 7 plus, that's 7.21 plus 3. So we get a final perimeter of 27.21. Alright, next problem. Find the area of a triangle with vertices H, O, and W. But how? So they tell us that it's a right triangle. So remember, to find the area of a right triangle, all you have to do is know this side, and the area of a triangle is 1/2 base times height. So we'll just do 1/2 x times y. So all we have to do is figure out which two sides are going to be perpendicular to each other, and then from there we can figure out the area by multiplying those two sides and then multiplying by 1/2. So let's do that. So first off, let's figure out the slope of each side to figure out what's perpendicular. So side HO, that is going to be a slope of, remember, it's change in y, in this case from negative 2 to negative 1, that's an increase of 1. And then change in x from 3 to 8, that's an increase of 5. Alright, so HO has a slope of 1/5. Let's take a look at our other sides here. We got OW. OW slope is going to be from 8 to 6. That's a decrease of 2. Oh, that's our bottom number though, because that's our x change. And then our y change, -1 to +9, that's a change of 10. 10 over -2 is the same as -5. Okay, and then our last side here, we have to do WH. And WH, change in y is going to be 9 to -2. And 9 to -2, that's a change of 11. And then 6 to 3, that's a change of 3. If we look at each of those slopes, all we have to do now is decide which one has opposite reciprocal slopes. So you may notice that HO and OW, their slopes are opposite reciprocals. So now all we need to do is find out how long each of those sides are and then plug it into our area equation. So the length of HO, what's really cool is we can use these values here from our slope, is 1 squared plus 5 squared. Take the square root of that. That is the distance every time for HO. So then we get 5 squared is 25, 1 squared, which is 1. So then that gives us the square root of 26. We can get an approximation in a minute here. And then OW, we're going to do the same thing. Remember, you have to use the unsimplified value, so the 10 and the -2, to get its distance, which would be 10 squared plus 2 squared, and that would be 104. The square root of 104. Now from here, all we have to do is put those into this equation. So area is equal to 1/2 the square root of 26 times the square root of 104. We can put all that into our calculator. We get 26 square units. Units squared. That's it. And again, that's because we found out if this was our triangle, this would be HOW, and then this side OW was the square root of 104, and this side was the square root of 26. So then we just took those numbers, put them into the area equation, and solved it. Alright, number 3, line segment is endpoints -3, 4, and 7, -1. What point would partition a line segment from T to O into a ratio of 2 to 3? Alright, so as soon as we see that ratio problem, we have to go back to that equation that we know for partitioning a line segment. And just put the numbers in. The key thing to remember is your ratio is always A colon B, and the starting point is always x1, y1, and the ending point is always x2, y2. And from here, you just put the numbers in. So we got B, and I like to set mine up like this. If you prefer to use the other equation, that's fine. This is the equation that I like to use. B plus A over B plus A, and then copy that again, B plus A over B plus A. And then we just got to put in our x values and our y values. So we do x1, x2, y1, y2. And then you just multiply it out. So that simplifies to 1, 2. That's all there is for that one. Alright, so next question, what is the area of a rectangle with points MA, TH? So with this, we're just finding the area. All we need to do, because think about for any rectangle, let's write MA, TH. And I don't really know if this is where they line up, but I do know it goes M to A to T, and so on. So if I can find this length and this length, all I have to do is multiply them, and that will give me the area. So I have to find the length of MA. Okay, so remember that's just my distance formula where I look at how far between X, that's 3, and how far between Y, 5 to 5, that's 0 square, and so that's just going to simplify to 3. And then I have to figure out how long is AT. Let's do a different color here. AT, same setup. From A to T, 1 to 1. On top. 1 to 1, that's a change of 0. And 5 to -3, that's a little trickier, but that is a change of 8 squared. And so from there, we get 8 simplified. And so to get our area, if MA is 3 and AT is 8, our area is just 3 times 8, or 24 square units. A circle in the coordinate plane has a center at 5, 3. What other point on the circle could create a line segment with the point on the circle 2, -1 to form a diameter of the circle? Alright, that sounds insane. Let's draw it out. So we have some random point of the coordinate plane, and that's our center at 5, 3. Then it says we have some other point that we want to find, and then we have another point on the circle at 2, -1, so something like over here, 2, -1 in relation to that 5, 3. So this is a radius, since that's a point. This is a radius, since that's a point on the circle. So basically, we just want this other point up here. What would that point be? So this problem, oddly enough, that's a midpoint. So we don't even have to worry about the actual circle part. All we need to do is say, well, if that's my endpoint, 2, -1, that's my midpoint, what's the other endpoint? So then what I'm going to do is I'm going to say, okay, I have an endpoint at 2, -1. I have a midpoint at 5, 3. So what is my other endpoint? If you remember this, we look distance from 2 to 5, that's 3 plus 3. So I'm just going to add 3 again and get 8. So my x value here is 8. Now the next part from -1 to 3, that's an increase of 4. I'm going to add 4. 3 plus 4 is 7. So 8, 7. Alright, let's look at 6. What's the distance between the two graph points? Round to the nearest tenth if necessary. So what's the distance between these 2 points? So we could use distance formula, but I find Pythagorean theorem to be a little easier. So let's make our right triangle here and just count. This is down 6 and over 6. It's just going to be the square root of 6 squared plus 6 squared. And that is the square root of 72, which is 6 square roots of 2, which is approximately, since they want us to round to the nearest tenth, approximately 8.5. Alright, next question. What is the midpoint of that graphed line segment? Alright, so if we get a midpoint, we want to know the middle point of the line. And so if you look, we can kind of guess if it's on the graph. It would be that point there, but let's do our midpoint equation just to make sure that we got that down. So we want to add up our x's, -1 plus 5 divided by 2, and 8 plus 2 divided by 2. Remember, that is your midpoint formula. The average of the x values, the average of the y values. 5 plus -1 is 4. 4 divided by 2 is 2. 8 plus 2 is 10. 10 divided by 2 is 5. If you look, that is in fact the point that we got there, 2, 5. Last question here, what point would partition this line segment in a ratio of 1 to 2? Same line segment, but we're doing a ratio of 1 to 2. So let's look at that in terms of our partitioning line segment equation, where we go b plus a over b plus a, comma, b plus a over b plus a. And then put in our x values, -1 and 5. Put in our y values, 8 and 2, and simplify. And from there, we get 1, 6. Okay, so let's check that point on the graph, see if it makes sense. 1, 6. Well, that point's definitely on the line. So let's see, how does that work? So if I'm going from -1, 8 to 5, 2, over 2, down 2. So that's one step. So to repeat that, I would just have to keep doing that 2, 2, 2, 2. So if you look, that's 2 steps on this side. So we got 1 step here, 2 steps there. So that definitely works as a 1 to 2 ratio. That's it.